We are asked to find a polynomial that has the given roots, -4 and -1 plus 2i. Now, one thing we'll notice right away is that -1 plus 2i is a complex number, so it's written in this format, a plus bi. Now, one thing that you have to know about complex numbers is that if a complex number is a root, then its conjugate is also a root. So what's a conjugate? Well, if we have a complex number written in this format, its conjugate is a minus bi. So in this example, -1 minus 2i would also be a root. So now that we know that, we have these three roots. So the way that we can write a polynomial is we just do x minus each of these roots multiplied together. So first we have x minus -4, which is the same as x plus 4, multiplied with x minus the next root, so -1 plus 2i, -1 plus 2i, times x minus the last root of -1 minus 2i, so -1 minus 2i. And that's all equal to 0. So we have to multiply out this whole left-hand side and see what we get. So it looks a little daunting, but the trick is that there will be some terms that cancel out between these parentheses with the complex numbers. So let's focus on these parentheses first. So I'll just rewrite the x plus 4. We get x minus a -1, that's x plus 1, and then minus 2i. And then in this parentheses, we have x minus -1, so x plus 1, and then minus a -2i, that's plus 2i, is equal to 0. Okay, so let's rewrite the x plus 4 again. And now, here's a trick we can use. We can group these x plus 1s together, like this. And when we're multiplying these two parentheses together, we're going to use the FOIL method, where we first distribute this x plus 1 to this term, and then we multiply it by the next term. So if we first do x plus 1 times x plus 1, that's x plus 1 squared, since there's two of them. And then what we'll notice is that we're going to do x plus 1 times a positive 2i, but then the next step will be an x plus 1 times a negative 2i. So because these two signs have the opposite terms, they're actually going to cancel out. So that's just going to cancel out. And the very last step is just going to be this -2i times a positive 2i, which is -4i squared is equal to 0. So next we need to recognize that I squared is actually equal to -1. So this we can treat as a -1. So that's a -4 times a -1, which is just a plus 4. So let's rewrite it as, we'll still have this x plus 4 right here. Now, x plus 1 squared, to expand that, we would get x squared plus 2x plus 1 squared is just 1. And we said this I squared is a -1, so we get -4 times -1 is a positive 4. So we could say plus 4. And if we want, we can just combine this plus 1 and this plus 4 right here. So let's say plus 5 altogether is equal to 0. So the very last step is we just have to multiply these two parentheses together. So first we'll distribute this x to all three terms in here, and then we'll distribute the 4. So first we get x times x squared is x cubed, and then plus x times 2x is 2x squared, and x times 5 is 5x. And then to that we add 4 times x squared is 4x squared, so I'll write it underneath this x squared. Plus 4 times 2x is 8x. Plus 4 times 5 is 20, so plus 20. So we get x cubed plus 6x squared plus 13x plus 20. And that is our final answer. So this is the polynomial that has these given roots.